All right, chapter 15, day 4. This is kind of a quick topic today, but what we're going to talk about is correlation. So what we're going to focus on is what is correlation. It's kind of a word that people use a lot, but in mathematics it has very specific meaning. So first of all, correlation, we use lowercase letter r to represent correlation. So if you see lowercase r, that stands for correlation, all right? And correlation is a mathematical tool to describe the strength and direction. So it'll tell me how strong a relationship is and whether or not it's positive or negative. So here's a couple examples here. So first of all, positive correlation, all right? In general, both sets of data increase together. So as the x is increasing, the y is increasing, we have something that's sloping positively. It'll have positive slope, positive correlation, okay? Correlation is a number between, if it's positive, between 0 and 1, all right? If it's positive. It cannot be bigger than 1. But the closer r is to 1, the stronger the positive correlation. So it's going to be a decimal, and the closer it gets to 1, the stronger the relationship is. An example of positive correlation between two variables would be the relationship between studying for an exam and the grade that you get. As one variable increases, the other would be expected to increase. And here's two pictures that I drew. The closer these points are to forming a straight line, the stronger it is. The more scattered they are, the weaker it is. So this would probably be like a positive 0.9, where this might be more like a 0.6. Correlation. All right? It's just a measurement of how strong an association is. So that way, without looking at the graph, if someone were to say it has a strong correlation, it's a 0.9, you know that the data is lining up fairly nicely. Whether it's positive or negative 0.9, it would line up negatively. So let's look at negative correlation. Negative correlation is like positive correlation, but in general, one set of data is decreasing as the other set is increasing, okay? One set is decreasing as the other is increasing, all right? It doesn't mean that it's not as good as positive correlation, it just tells you which direction the data is headed. So negative correlation has a negative slope, if you look at the line that fits the data, and it, as small as it can get is -1, and then it could get as high as almost 0. If it's 0, then it's called zero correlation, all right? But the closer r is to -1, the stronger negative correlation it is. So, and again, the more closer to forming a straight line with the dots, the more closer it is to that -1. An example of negative correlation would be the relationship between absenteeism from school and class grades. The more you're absent, the lower your grade. It's a negative correlation. No correlation, I wouldn't even put a line through the dots, because the best fitting line, actually we call this zero correlation, would go that way. That line would best fit the dots. It has zero slope. The r is close to 0. The weaker the correlation, all right? The closer r is to 0, the weaker the correlation. A correlation of 0 does not always mean that there's no relationship. It just implies that the relationship is not linear. The best fitting line would be horizontal. There's no slope to it. I don't like the example they give. I give how old you are and how many pets you own at your house. There probably isn't any correlation between the older I get, the more pets I have, or the less pets. If I drew a scatter plot of that, it would just be dots all over the place on the graph. And the line that would fit the data would just be horizontal, okay? So that's zero correlation, all right? So some of the examples, the way that we see these on tests might be in multiple choice. For example, a regression equation, that's what we just did in class. A best fit has the equation. Now I'm going to rewrite this so it's easier to see. H equals 0.5x plus 68.5. All right? The correlation for that data would be what? Well, here's the choices. Is it between 0 and 1, so is it positive? Is it between 0 and -1? Is it negative? Is it 0 or is it straight -1? Well, what did we say about correlation? We said that depending on the slope, we know whether it's positive or negative. Positive correlation, positive slope, negative correlation, negative slope. So, since the slope is positive, the correlation is positive, okay? Since the slope is positive, the correlation then is positive. So the only possible answer that's positive is choice 1. All right, and so sometimes reading the equation you can tell whether it has a positive or negative correlation. Here I have a bunch of dots, all right? So this one has positive correlation. This has positive correlation. This, again, if I were to draw the line that fits the data, that has 0 correlation. This has negative correlation. Which scatter diagram shows the strongest positive? So I need strong and positive. Well, here's 2 positives. This one forms more of a straight line than this is scattered out. So here's my strongest positive correlation. And so we're going to do problems in class that just deal with whether it's identifying correlation, picking it out from graphs. I'm going to show you on the calculator how you get the correlation value. It's going to be part of our regression work, and then you're going to see where correlation is listed on the calculator. But that's it for today.